So hi guys, it's me Deepak and welcome back to another video. This video will be about sparse matrix. So here's the matrix with no zero element, and it makes sense if we store it like this. But what if you have an element with barely any non-zero elements? So we will be wasting a lot of time here, and that can be required for some other purposes. So here's an 6x6 matrix, and each block in nowadays will store 4 bytes. Earlier it was 2 bytes, but now it moved to 4 bytes. So we will be storing around 144 bytes of data for this 6x6 matrix. Now let's see another matrix. It is also 6x6 matrix, which is 3 non-zero elements. So again, we have 36 elements and 145 bytes. But here we only have 3 non-zero elements. That's like 12 bytes. So we will be wasting around 132 bytes of data just to store the 3 non-zero elements. Rather than doing this or wasting a lot of space and computation time, you can store them in other ways also. So as you can see, there were 3 elements. I have also marked them. It doesn't make that sense. So how can we save them? How can we save the time? You must be thinking the same thing. So rather than storing like this, we can have another element, and we can store just the row, the column, and the value of the non-zero elements, as you can see on the screen. This way it's like 9 elements rather than having 36 elements. It will be like 9 plus 4, 36 bytes of data rather than 144 bytes of data. And it's just a small example. There can be bigger matrices like 100 cross 100. So it's win for all. So storing like this makes sense. Now let's add 2 matrices. So you have another example of matrices with barely any non-zero elements. Adding them like this will waste time and effort and energy. So we will add them like this. This makes so easy. So if the rows and columns are same, we will just add the values. On the other hand, if rows are smaller, we will place the smaller ones first. If the rows are same, then we compare the columns. If the column is smaller one, we will place that one first, then the next one. So we'll be iterating rows of these matrices and adding them or placing them while we are adding. So this saves time, it's more efficient, and it will be used later on in other algorithms like graph algorithms like DFS or BFS, depth first search, breadth first search. So far we have seen how we can add these elements and how it's make much more sense than adding them like traditional ways. So placing them, iterating through the loop, as you can see on the screen also, we can compare them, iterate them, move to the next row. So let's see how we can do this in a C++ program, and what will be the condition and what will be the time. So we're gonna start by importing our input output stream, because we're writing the code in C++, and then using namespace std as always. So if you're used to Turbo C, it's 2020 man move. Start using IDs, other IDs that are good ones. So I'm using test data. So first we will start by creating our sparse matrix class. We will place everything in public here. If you want, you can place it in private. So start by int. We'll get double pointed data that will store a sparse matrix. We'll define row, column, and length. We will store the row and columns and length of the matrices. Length is gonna have the number of rows of sparse matrix here. So just keep that in mind. And rows and columns are of the normal matrix here. So let's create the constructor here. So we'll first pass the value. Whenever we will create the object, we will define the row and the number of rows and column of that matrix, because the objects will be different matrices here. So we will define the row equal to r, column equal to c, and then length equal to 0. Length will be initialized here with 0. And also I think I forget to place our, because we will have to define the number of rows in that matrix first. So I have a static constant int max equal 100. Here this max variable will have the number of rows of that sparse matrix. You can have any value you want. So we will start by defining the creating the space using new operator. So new int pointer max will be 100, so the rows will be 100 here, and each row will have 3 columns. So we create a for loop, and then we'll store the columns here. So 3 columns, rows, columns, and length. So guys, if you have liked this video, so like and subscribe. So just a plugin, I think I deserve this one. So now let's create our insert function, because first of all let's create the objects here, a and b, that will have columns here, 4, 4, and then let's make the insert function here, we're gonna pass the row, the position, not the rows, the position of that row, the column, and the value here. So if the element was in 4, 4, 3, so I think you got the clue here. And then the if condition, because we're gonna check, we don't want the row and column to exceed that we're inserting, we don't want any error here. So this, just to get that out of the scenario here. So else case, and then okay. So now we're gonna have a else condition where we will store the the row, the column, and the value that we have passed as an argument, as in the insert function. So we'll be passing the values from our main body, and then we'll be storing them. So data is our sparse matrix, and it will have length. So for each row there will be different row, column, and value. So 0th position will define our row, first position will be our column, and second will be our value. So just keep that in mind, that every row has a different non-zero element, different positions, and then we will increment length. So for first row it will have different non-zero element, then different and different. So far we have created the sparse matrix, we have inserted the values. So as you can see, I have made 2 classes, 2 objects of a class, a and b, and it will be inserting values here. So insert 1 2 3 1 2 3. So as you can see, the first a and the insert functions have same value, 1 2 and 3 1 2 and 6. So the result should have, and we'll be adding 1 2 and 6 will be the value. Now we'll create an add function, and we'll be passing the object b. So let's create a temporary object that will store our the values that will be added, and the row and column. Just for now, it will be for this add function only, scope will be limited, and it's gonna have row and column as because result object should have the values of the parameters of the constructor. So it will have row and column, and then we'll create 2 temporary variables, a position and b position, for storing the position of rows of the a class, of a object and b object. So we will be iterating through the rows of both the classes and comparing their rows and columns. So as you can see, data a position 0, we will first start by comparing the rows. If the rows are same, we will compare the columns, and if rows are smaller, we'll put the smaller value first we will place the smaller value first in the result object, inserting the smaller position first. If rows are same and columns are smaller, then also that smaller one will be placed first, and then the second one. So it's just that, and then we will create we have already created the insert function, so we'll be inserting our data, a pos, or whatever is smaller or bigger. So if in this if condition, we will be inserting our b object, because this condition is true, then that means our b object first value is smaller, a row or either column is smaller, and we will be inserting it and also the value, and then we will increase our b position, so it will move to the next row. Just keep that in mind, keep that the sparse matrices of a and b in mind, and we will be iterating through the rows. And then for next if condition, if a pos row or either column is smaller, then we insert our a object, row of the a object in that in our temporary object result. And then it's our else condition, But if both rows and columns are set, then we begin by adding the values. So I have created an temporary variable adder that's gonna add the values of a pos. So remember that second column was the, or should I say the third column was the values one. Array start from 0. It's meme nowadays. So we start by inserting the value then adder, and we increment both a position and b position in this case because we have used this one, and then let's move to next. And but now we need to check if what we have written so far is true or not. So we'll so first, if there can be conditions where b pos, because the while loops have both the conditions to be true. But if a pos, or what if the row, there were more rows left in a object that were not used because b was smaller and b finished and the while loop ended, so the later element should be added. So in this case also there is one thing to be to kept in mind, that the object, the order in which the we are inserting our objects, or inserting the values, it should be in ascending order. So if when we at the end, when we are inserting the last few elements that were left out of either a or b, it should be in order wise, because otherwise you will have a jumbled value, and that won't make, because we are inserting in them in ascending order, and then there come an element which doesn't fit there. So now let's have a word print, because we will need to print result dot print for int I equals 0, I length, and lsn normally, and we'll print the row and the column and the value. And then let's make a call in the, no, we don't even, we have already made the call. Yeah, we don't have make the call to add. I'm going to specify it first. So also there's an error here. Yeah. Oh. So I have not made the call for add, so we first need to make that one. So I use Sublime Text Editor to write the code, because it put less strain on my eyes. If you don't hate your eyes, use something like which had dark theme or Visual Basics. So here you can see the, I told you earlier that the rows and the rows and the column of the first elements were same, so we will just be adding values. So guys, thanks for watching. If you like this video, press like, subscribe. If you have any questions, comment the section below. And as always, stay safe, guys.